All right, so we're now moving on to our next section of this unit, and that's going to be section 3B, and we're talking and discussing about identifying and combining like terms. So our learning objectives for this video is first, and if you're going to be able to identify or combine like terms, you need to know what just a term is. So students will know what a term is, and then you'll know, well, if we know what a term is now, now we're going to know what are like terms and how to identify them, and then we're going to be able to combine like terms. So this whole video is just going to be talking about terms first, and then identifying like terms, and then combining them. All right, so let's go ahead and talk about what terms are. All right, so a term is a single mathematical expression. So you should know the difference between an expression and an equation. For instance, if I just write x, that is an expression. But if I say x is equal to 5, that then becomes an equation because we have that equal sign. So a term is just a single, and that's the thing here too, single mathematical expression. So I'm going to write a problem on the board up here, which is kind of what we did in class before. If I had negative 4 squared plus 3 times 2 divided by 6. Let's just say minus 4 times 3. We're going to talk about this in just a moment. But this here, when we were learning the order of operations before, we actually had a string of expressions. And remember, I talked about we could highlight everything that's in between all of those plus and minus signs. And that's what we would be looking and focusing on in each of our parts of our order of operation, because it was breaking it down into terms or into parts. So each of these, this yellow, green, and blue, they all represent a different term within this problem. And remember, we talked about the pluses and the minuses are what separated our terms. And everything, if it was just being multiplied and everything multiplied in division or powers in between, that would be considered one term. So when we're looking at here, it is a single mathematical expression. So when we say that, we're looking at them as individuals. So this here is one term, this here is another term, and this here is a third term. So when we're looking at terms, they are a single one. So we wouldn't be looking at the yellow, green, and blue all together. We're looking at all of them individually. And if you notice, I said that the plus or minus is what separates our terms. And you're going to see when we actually go through here what a term is, none of them can be added or subtracted. Multiplying is okay, though, because when we multiply that, it will give us this one number within that expression. Whereas when we finish simplifying all this multiplying, we would have three numbers, 1, 2, and 3 numbers that we would then add or subtract. So when we're looking at a term is just representing essentially one number. Yes, we might see 3 because we have 3 times 2 divided by 6. So within this, I might see 3 numbers. But when we simplify and multiply, it will break down to one number before adding and within that expression. So that's what we're looking at here. A term is just a single mathematical expression, and it can appear in multiple ways, as it says. So it can just be a single number, positive or negative. So for A, we can have a positive 5 or a negative 3. Those are both considered terms. It is a single mathematical expression. It's just a number, and that is our term. For B, it says that it can be a single variable, which is a letter, and it can have any exponent. So x can be an expression, x raised to the fifth power can be an expression, negative y can be an expression. So just a variable itself raised to any power can be or is its own term. For the next part, for C, it could be several variables multiplied together. But remember, never add it or subtract it, because once they're added or subtracted, it actually creates two separate terms. So for C, we can have x, y, and z. That's three variables that are being multiplied together. When the variables are just being written next to each other like that, it's understood that they're being multiplied. We can have negative a, b, c. We can have, let's say, m squared n to the third and o to the fourth power. Like, all of those are still just considered one term, because the only thing happening in between them is multiplying. And remember, it's the pluses and the addition and subtraction that separate our problem into new terms. And that's why here we say can never be added or subtracted. And then as I already kind of wrote with the negatives, but for D, we can have a number in front of that variable as well. We can have 3x, we can have negative 4y, we can have 10z. All of these are considered terms as well. And when we write 3x like this, it's actually 3 times x, or negative 4 times y, or 10 times z. So when we write the number next to the variable like that, it is being multiplied, But the one thing that you do need to know is that this number in front of the variable has a very specific name, and it is a coefficient. So when we start combining our like terms, you're going to hear me talk about coefficients, and that's the number that's being multiplied to our variable, or the number that's written out front, and it's telling us that it's being multiplied. So -4 would be our coefficient here, and 10 would be our coefficient for that last one. All right. So a term is a single mathematical expression. If we were to write instead of x, y, z, x plus y plus z, well, this would be three separate terms. We would have our x will be one term, our y would be the second, and z will be the third. So terms are broken up by the addition and subtraction. If it's being multiplied, divided, that's all within one term. Raised to a power, that's all within one term. But once we add or subtract, it's now creating a different mathematical expression, which then means it is a different term. All right, so now let's go ahead and talk about like terms. All right, so first off, if we're going to be talking about and combining like terms, what are they? So what are like terms? And like terms are defined as terms that contain the same variable, which is raised to the same power. Right, so this is what you have to. It just needs to be identical. When we're looking at our variables, the variables need to be identical in every way. And we're going to go through a bunch of different examples here to show you where things are identical and where things look or appear to be really, really close, but they're not. So everything within that term, all of your variables that are within that term need to be identical to each other. All right. And in algebraic like terms, only the numerical coefficient, so only the coefficient can vary. So the coefficient doesn't have to be the same because that's telling us how many we have of it. But the variable or variables that are within that term need to be identical to each other in all ways. Constants are like terms, and we're going to talk about that in a moment if you're not sure what a constant is. So first off, x and 3x. These are like terms because the variable that is presented there, x, is the exact same. It's the exact same variable, x, and it's being raised to the same power. And if you're not sure, when there's no number written to that power, it's understood to be 1. So those are both x raised to the first power. So even though this has a 3 in front of it, that's our coefficient, and that just tells us how many of those variables we have. We have 3 x's here, whereas in this one, when there's no number written there, it's understood to be 1. So we have 1x there and 3 on the bottom. That's just telling us how many, but our variable is identical. All right, another example that we can have is y squared, and let's say -2y squared, and let's say 5y squared. So once again, these are like terms because they have the exact same variable y, and that variable is raised to the exact same power 2. So both of our variables here are y squareds. So they would be considered like terms because their variables are identical. Now the numbers in front are a coefficient that just says how many we have. Well, we have -2 of that y, and we have 5 of these y squares as well. All right. Now here's one that may appear to be like terms. Let's say 5y and let's say 6y squared. These may appear to be like terms, but they are not. And the reason why these are not like terms is yes, they both have the variable y, but this one has a y squared, while this one is y to the first. So you see their powers aren't identical. They both have the same variable, but in order for them to be like terms, they have to match exactly. All right, and we'll talk about this in class as to why they're not like terms, but just for interest of time for the video, we're just going to just point out these aren't for right now. All right, so those are not like terms. And then let's go ahead and start adding more variables to the mix. Meaning, if I give you 3ABC and then I give you 6ABC, well, these would be considered like terms because we can have multiple variables being multiplied together in a term, and they're all identical, meaning A matches up perfectly with A. They're both A to the first power. B matches up perfectly with B because they're both B to the first power, and C matches up perfectly with C because they're both being raised to the first power as well. Remember, the number up front is just how many we have of them, and they don't need to match. All right, so but now once we start adding more variables to it, now this is where it can get a little bit tricky. If I say A squared BC, and now let's say 6A squared B squared C, are these like terms? And this answer would be no. These are not like terms. And it may appear to some that they are because we see, well, we have A and we have A. We have B and we have B. And we have C and we have C. Well, we have the same variables, so why aren't they like terms? Well, the reason why they're not like terms for that is because their powers don't match. So yes, for our a's, they're both a squared, so the a's match. So the a's would be considered like terms within that if that was its own term. However, if you look at the b has a squared and this one doesn't. So since the b's don't match and this is all one term, this is not a like term. So all the variables within the term have to match each other exactly. So although the A's and the C's match perfectly, the B's do not. So these are not like terms. All right. So our like terms, all the variables within it have to match perfectly. So if I have 6x cubed, y to the fourth, and z to the second power, well, 5x cubed, y to the fourth, z squared, they would be considered like terms because everything that all of our variables match. We have x cubed, we then have y to the fourth in both, and now we have z squared in both. So you see, in order for them to be like terms, all of the variables have to match. And now the last thing we're going to talk about are constants. Well, what are constants? Constants are just numbers. 5 is a constant. 6 is a constant. Negative 28 is a constant. Negative 1035 is a constant. So all of our just numbers are constants. And they're constants because those numbers don't change. 5 is 5. That can't change. X is a variable, so we can substitute something in for that X, and that X can change. It could be, we could substitute 2 in for it. We can substitute 10, etc. So those variables can change because they represent something, an unknown value, and they can change. So constants, 5 is 5. That can't change. All right. So our constants are all like terms. So any number that we just have as well that isn't being multiplied to a variable, those are all considered like terms. Even if it's squared, even if it's 5 squared and we have 32 down here, they are like terms because 5 squared actually represents 25. And we know that number. We don't have to wait for something to be substituted and solved for that. So they would then eventually become like terms once we were to simplify or square that 5. All right, so now we're going to talk about combining like terms, and then we're going to go through some examples with it. All right, so combining like terms. Well, what we do is we are adding or subtracting our like terms. That's what we mean when we say combine. And all we're simply doing is adding or subtracting the coefficients, which is the number in front of the variable, remember. So if a variable has no number in front of it, as I talked about, it's understood to be 1. So if I say x, this is understood to have a 1 here, as I've already mentioned that. But if I say negative x, well, this is understood to be negative 1. So no number in front of the variable is understood to be a 1. And if it's positive, it's positive. Positive, if it's negative, it is negative. All right, so now let's go ahead and talk about combining some like terms. If I give you 3x plus 4x, well, before we can add these, we first need to make sure that they are in fact like terms. Well, both of our variables are x. They're both being raised to the first power, so they are identical. So the way that we combine our like terms is we simply just add the numbers in front. So we can do 3 plus 4, and that's still being multiplied by x, and 3 plus 4 is 7, so that is 7x. Because remember, this 3x tells us we have 3 of them, x, and we know that we can rewrite multiplication through repeated addition. So this 3 times x is the same as x plus x plus x. This 4 plus x is the same as x plus x plus x plus x. And then since we're adding them in between here, well, we're saying, whoops, it was supposed to be addition. We're saying, well, how many do we have total? Well, now we have 1, 2, 3, 4, 5, 6, 7 x's. So it should make sense to as to why, if you understood that the coefficient says how many we have, that why it is 7x. And repeated addition can be rewritten as multiplication. So 3x plus 4x is 7x. So we're just adding the numbers in front. If I give you, let's say, 3x squared minus 4x plus x squared plus 3x. Well, from here, when we're looking at our like terms, now what you're going to start to see me do is I'm going to start underlining with different colors, and you should maybe use highlighters or different colors. We have all that in class. So here are my like terms of x squared and x squared. And here are my like squares of minus 4x and plus 3x. So when I'm combining these like terms, well, my x squares, I have 3. And this one is understood to be a 1. So it's 3 plus 1 times x squared. And then from here, we're going to add in between. And then after, we're going to see what the sign has because we're focusing on these numbers on themselves. So here we have minus 4 of this x. And then we have plus 3. So minus 4 plus 3x. And now 3 plus 1 will give me 4x squared. And then here, minus 4 plus 3 is going to give me a plus. And then we have negative 1x. But we never write plus minus, so it would simplify to be 4x squared minus x. All right, so we're just simply adding the numbers that we have in front, and that will then combine our like terms. We're going to go through a couple more examples of real examples with it. I mean, these are real, but like where it's just a little bit more. We're going to go through a couple more examples, and that'll be it for this video. All right, so these are the last two examples that we're going to go through. And I'm going to go through them one by one. So let's go ahead. First thing I'm going to do is, for example 1, I'm going to highlight all my like terms. So here I have 5y, here I have 4y, and those are my only like terms with my y, because this is a y squared, so it's not actually a like term. There's no other y squared, so there's no other terms that are like with that. Here I have minus 2x plus 8x. And then my last one that I have that I can go ahead and highlight is this minus 11 and plus 7, because they are constants. So now when I'm putting these in parentheses like this, you don't have to show me this work, but it's good for you in the beginning if this is something that's new to you. So with our y's, we have 5 plus 4y, and now I can cross them out, and then it's going to be plus. And then with my x's, I have negative 2 plus 8, and that's going to be x. Then I have plus 7 minus 11 and minus 2y squared, because there's no like term for that one. And then from here, I'm just going to add this. I have 5 plus 4 is 9y. Negative 2 plus 8 is 6x. 7 minus 11 is minus 4. And then minus 2y squared. And then just the way that you will have to write, if you can end here, you're going to get full credit. But the way that you will have to write this in the future is when you have a variable that's raised to a power, we usually write that variable first in descending order, meaning that we start with its highest power, and then we write it until we don't, we'll have squared then to the first, and then we have no other variables to write for that, so we'll move on to our next one, plus 6x and minus 4. Usually we do try to write these in alphabetical order, so x will go first, but since y has that squared, we could write this as y squared first and then y, and then we go to our next one after that. I'm not going to be a stickler for how you're writing in order right now, because I just want to make sure that we can combine like terms, and then in the future we'll start worrying about the proper order. All right, so then for this next one here, I have x squared, and then I have another x squared, so there's my like terms for that one. I have just x's, and then I have my constants as well. So now I am going to write these in the proper order right away. So I'm going to do my x squareds first. So let me just draw a line going down here so we can separate. So we have 10 minus 2x squared plus negative 3 minus 6x plus 4 plus 8. And then from here, 10 minus 2 is going to give me 8x squared. Negative 3 minus 6 is negative 9. So a positive and a negative is going to be minus 9x. And 4 plus 8 is 12. And that will be my final answer. All right, that is it for this video.